So today we are doing problem 1473 paint house free. So basically we have m houses and each house needs to be painted with one of n colors from 1 to n. Some houses are already painted, for example here houses 2, 3 and 4 are painted with colors 2, 1 and 3, 0 means it's not colored with anything. Cost is a matrix which in each row j entry tells us how much does it cost to color house with index I with color j plus 1, and then we get the target, which means what's the meaning that we should paint the house in with minimum, paint the neighborhood or paint the houses such that there is exactly target neighborhoods, and the neighborhood is essentially a continuous sequence of houses. So this is a neighborhood, this is a neighborhood, this and this. So what is our state? This obviously is a DP problem. So what do we have? Okay, so we need to know which house we are on, how many neighborhoods do we have, and what is the color of the house we did. And for that it's important to check. So this is number of houses we have, number of neighborhoods is this, so basically m squared, so 10,000 times the color, that's 20. And now so we are at roughly 200,000. And now what are transitions? Because if I try to paint, of course when we are at some painted house the answer is like infinity for all colors except the one placed in. If it's 0, right, then we have to go through we just check dpi minus 1, and from there how many neighborhoods. We basically check all colors, and based on the color we know if we check the same number of neighborhoods or less. Okay, and the base case is cost is 0 if we color 0 houses in 0 neighborhoods for all colors, I guess. So I mean that's kind of tough because that's like 4 million. That should pass. So let's do it. So mln houses and mln costs 0. Oh, I have those values. Okay, so let's do dp. And then one thing we can already notice is that the values will only depend on dp minus 1, so we could theoretically immediately do that optimized dp, but it's easier to just rewrite it after you make the logic. So I think we need to define the infinity. So let's do what are the costs. 10 to 4 times 100 houses 10 to 6, so that's okay. Number of colors, number of neighborhoods, so that's like target plus 1, and number of houses, and then dp for I guess we could do colors like this, but whatever. dp 0 0 I is 0. So we fill the dp one by one. Now we go through number of neighborhoods, and we can have 1, 2, 1 to min of target I plus 1, because we usually would go for target plus 1, but I mean we cannot get 5 neighborhoods from first 3 houses, so we take minimum. And then for current color in range, in range 1n plus 1 if houses I minus 1 0. If houses I minus 1 doesn't equal 0, then cost to paint each house is equal to 0. I mean technically cost houses, so to paint that exact house should cost 0 money, I think. Oh, we can recolor. Should not be painted again, so we cannot recolor. Okay, and then for current color in range this, if houses I minus 1 doesn't equal 0. Else what? I don't know. Else it's just so if it is 0, okay, so and then previous color right, and then so dpij current color is equal to mean dpij current color and dpi minus 1, and now j minus, and we subtract 1 if current color doesn't equal previous color. Maybe actually I should not do this. Because then with one neighborhood, yeah, nah, I will do it. So else it's 0, and then ref color plus cost okay, and then for color in range dp m target like this. What do you mean out of range, bro? so else if inf else -1. Okay, let's see. Wrong answer. Expected 0. I mean, 2 cases wrong only, so I guess we are already clear to use like NDP, right? NDPJ, this is DP, okay, and then we need to construct NDP, and then we need to do like DP and DP, so we basically save memory. Problem is, this is still wrong. Let's just print current color to see what colors we are trying. We should only be coloring one, right? Yes. So let's print DP cost current color -1. So it costs 0. Okay. And then how much is this? Oh, we need to, okay. Okay. So we needed to color one neighborhood. I mean, it doesn't quite make sense because one zero. I guess I don't think this should break the answer. Let's see. Okay, so we beat, okay, we are in like basically the top. That's cool. So I mean, our solution is space complexity, it's target, so like m times n, and this is m times n times n, which is a bit excessive. Let's see, m times target times n squared, bottom-up dynamic programming, space optimized. Okay, fair enough. Not the most, quite straightforward actually. If you want a more difficult recursion, you could try to think about a paint the fence problem, and if you manage to get the recursive relationship, then you should try doing it in sublinear time. Anyways, 3DGP O M T n squared space is OMT no T tn time. Okay, so sounds like a DP problem, so let's think about the state. We need to know which house we are currently on, how many neighborhoods are created, and what is the color of the current house, i.e. dpijk is mean cost to color houses 0i with exactly j neighborhoods with house I having color k. What are the base cases? So that well, to color 0 houses with and having 0 or 1 neighborhood last and the last house having color can have any color costs us 0. All other cases, since we are solving a minimization problem, let's set all other cases to something, to inf 10 to 9. Okay, so let's call this, or I mean recurrence. So for each house and each number of for each house we try all numbers of neighborhoods up to I, so there can be 10 neighborhoods from 3 houses. Colors of last house. Which previous states care about? Well, only what the color of the previous house was, since that determines what is the number of neighborhoods up to the previous house. Either the same it take minimum over previous states plus cost to color the house I with color and which is 0. Note that only try one full color for already houses and set its painting cost to 0 to make our lives easier. We have O, M, T, N squared states where T is target. For each we check ON previous states or other slash previous states. So our time but notice that each state of house for house I only depends on states of house I minus 1, so we do not need to store the entire 3D table, rather just the last two matrices, reducing our space complexity to OPN. Okay, I mean, not the worst hard problem of all time. Maybe it's because I was doing the Leetcode whatever problems, and I know half of basic BP, and this was quite basic. So see you tomorrow.